Lesson is about sum and difference identities per sign. So in this lesson, we have two important formulas that we need to remember. So first is we have the sum identity per sign. So we have sine alpha plus beta. The formula is we have the product of sine alpha, cosine beta, plus we have the cosine alpha and sine beta. Next is we have the difference identity per sign. So we have sine alpha minus beta. The formula is the product of sine alpha and cosine beta minus the product of cosine alpha and sine beta. So in this lesson, we will be needing a unit circle. So this one is our unit circle. So in this unit circle, we have the degree measure, the radian measure, and its ordered pair. So remember that in our ordered pair x and y, x is the value of your cosine, while your y is the value of your sine. And aside from that unit circle, we will be needing the trigonometric functions. So we have the sine theta that is equal to y over r, the cosine theta that is x over r, tangent theta y over x, while x is not equal to 0. Okay, cosecant, we have the r over y, the secant theta, we have r over x, and cotangent theta, that is x over y. Take note that the denominator should not equal to 0. Example number 1. Find the exact value of sine 15 degrees. 15 degrees is not a special angle, so you cannot find 15 degrees in our unit circle. So this time, we will be needing the sum and difference identities per sine to find the exact value of sine 15 degrees. And to do that, we will be needing our unit circle. We will be needing the special angles inside our unit circle. So first is you need to find a combination of two special angles that will result to 15 degrees. It can be addition or it can be subtraction. So first combination is we have 45 degrees minus 30 degrees. It will result to 15 degrees. Next is we have 60 degrees minus 45 degrees. Third is we have 135 degrees minus 120 degrees. And again, guys, aside from these three combinations, we can have more combinations that will result to 15 degrees. So it's up to you kung ano ang gagamitin mong combination. So, but this time, we will be using 45 degrees minus 30 degrees. So, we will be using the difference identity per sine to find the exact value of sine 15 degrees. So, we let now our alpha is equal to 45 degrees and our beta now is equal to 30 degrees. So, let's have the formula for the difference identity for sine. So, we have now the product of sine alpha and cosine beta minus the product of cosine alpha and sine beta. So, after this one, let's substitute the alpha and the value for beta to our formula. So, this one, we have now 45 degrees minus 30 degrees. And let's replace all alpha and beta in our formula. So, sine alpha now becomes sine 45 degrees. Our cosine beta becomes cosine 30 degrees. Copy the minus sign. The cosine alpha now becomes cosine 45 degrees and sine beta now becomes 30 degrees. So after substituting the given value to our formula, we will be needing now our unit circle. We need to find the exact value of these trig functions using our unit circle. So first is, let's find the value of sine 45 degrees. We have 45 degrees, this one is 45 degrees, and this one is the ordered pair. Since we're looking for the sine function, that is the y value. So, this is the y value, that is square root of 2 over 2. So, let's change the sine 45 to square root of 2 over 2. Next is, we have cosine 30 degrees. So, this one now is our 30 degrees. Since we're looking for the cosine, that is the x value. So, here is our x value. It is equal to square root of 3 over 2. So, let's replace our cosine 30 degrees to square root of 3 over 2. Copy the minus sign. And then, let's have the exact value of cosine 45. So, this one is the 45. This one is the x value, that is equal to square root of 2 over 2. So, this one now becomes square root of 2 over 2. And last one are sine 30 degrees. This one is the ordered pair and that is the y value, meaning that's equal to 1/2. So, sine 30 is equal to 1/2. And after that, we can now proceed to our basic arithmetic. So, find the product of square root of 2 over 2 and square root of 3 over 2. And then minus the product of square root of 2 over 2 and 1 half. So, that is equal to square root of 6 over 4 minus the product of these two is equal to square root of 2 over 4. And this one now is a similar fraction. So, we simply subtract the numerator and copy the same denominator. So, we have now the exact value of sine 15 degrees is equal to square root of 6 minus square root of 2 all over 4. Number 2, find the exact value of sine 165 degrees. Again, 165 is not a special angle. So, we will be needing the combination of two special angles that will result to 165 degrees. I will show you 3 examples of combinations. We can have 120 degrees plus 45 degrees. You can also have 135 degrees plus 30 degrees. And you can also have 315 degrees minus 150 degrees. Again, there are more combinations of two special angles that will result to 165. So, but for this time, we will be using 120 degrees plus 45 degrees. So, we have now the sum identity for sine to find the exact value of sine 165 degrees. So, we'll let now alpha is equal to 120 degrees while beta is equal to 45 degrees. And the formula for the sum identity for sine is equal to the product of sine alpha and cosine beta plus the product of cosine alpha and sine beta. So, we replace now or substitute the value for alpha and beta to our formula. So, we have now sine 120 degrees plus 45 degrees. Let's replace all alpha and beta in our formula. So, sine alpha now becomes sine 120 degrees. Our cosine beta becomes cosine 45. Copy the plus sign. And then the cosine alpha now becomes cosine 120 degrees. While our sine beta now becomes sine 45 degrees. And this time, we will be needing the exact values of these 4 trig functions using our unit circle. Okay, first is, let's find the exact value of the sine and cosine for 120 degrees. So, this one is our 120 degrees. Again, the sine value is the y value where our cosine value is the x value. So, meaning, pag hinanap natin si sine, that is square root of 3 over 2. So, palitan natin ito ng square root of 3 over 2. While our cosine 120, that is the x value, that is equal now to negative 1 half. So, yung cosine 120 natin, let's replace that as negative 1 half. So now, let's proceed to the sine and cosine function for 45 degrees. This one is the 45 degrees. And if you will observe, pares naman silang square root of 2 over 2. Pares natin cosine and sine. So, si cosine 45, that is square root of 2 over 2. While our sine 45, pares lang din siya square root of 2 over 2. And simply copy the plus sign. And after this one, we can now simplify square root of 3 times square root of 2, that is equal to square root of 6. And then 2 times 2, that is equal to 4. So, the final answer now is square root of 6 over 4. Copy the plus sign and negative 1 half times square root of 2 over 2, that is equal to negative square root of 2 over 4. So, this time, let's simplify. So, this one is a similar fraction. So, let's add the numerator and simply copy the same denominator, which is 4. So, the exact value now for sine 65 is equal to square root of 6 minus square root of 2 all over 4. Number 3, find the exact value of sine 7 pi over 12. Again, 7 pi over 12 is not a special angle. So, we need to find now a combination of two special angles in radian measure that will result to 7 pi over 12. So, this time, we will be using the combination of pi over 3 plus pi over 4. Again, there are more combinations of special angles in radian form that will result to 7 pi over 12. But this time, we will be using the pi over 3 plus pi over 4 to find the exact value of sine 7 pi over 12. So, we will be using now the sum identity for sine to solve this question. So we let now our alpha is equal to pi over 3 while your beta is equal to pi over 4. And this one now is the formula to solve this question. And let's replace the alpha and beta by its value. So we have now sine pi over 3 plus pi over 4. Our sine alpha now becomes sine pi over 3. Our cosine beta becomes cosine pi over 4. We simply copy the plus sign. The cosine alpha is cosine pi over 3. And sine beta now becomes sine pi over 4. And this time, we will be needing the exact values of these 4 trig functions using our unit circle. So let's start with the sine and cosine function for pi over 3. So ito ang ating pi over 3. Again, this one now is our ordered pair. We have the x and y. Again, if you're looking for the cosine function, that is the x value. Your sine function is the y value. Meaning, if we're going to find sine pi over 3, that is square root of 3 over 2. And your cosine now becomes 1/2. So let's replace this one as square root of 3 over 2, while your cosine pi over 3 is equal to 1/2. And now let's proceed to the sine and cosine for pi over 4. Our pi over 4 is here, and this one is our ordered pair. Since parehas naman siyang square root of 2 over 2, meaning our cosine pi over 4 is square root of 2 over 2, while sine pi over 4, square root of 2 over 2 din siya. And simply copy the plus sign. And let's simplify now. Square root of 3 over 2 times square root of 2 over 2, that is equal to square root of 6 over 4. Copy the plus sign. 1/2 times square root of 2 over 2, it will result to square root of 2 over 4. And this one is a similar fractions. So the exact value now of sine 7 pi over 12 is equal to square root of 6 plus square root of 2 all over 4. Let's have another solution for number 3 in finding the exact value of sine 7 pi over 12. So in this time, you are given a reason measure. So instead of finding a combination of two special angles in reason measure that will result to 7 pi over 12, which is harder for us to think all the combinations, why not we change first the 7 pi over 12 into degree measure so that it is easy for us to find the combinations that will result to that value of angle. So first is we change the value of 7 pi over 12 to degree measure. And you multiply that by 180 over pi, and that will result to 105 degrees. So now we are given what is the exact value of sine 105 degrees. Again, 105 is not a special angle. And we will choose the combinations of two special angles, that is 60 degrees plus 45 degrees. Okay, so this time we will be using the sum identity for sine to find the exact value of this sine 105 degrees. So we let now alpha is equal to 60 degrees while your beta is equal to 45 degrees, and this one now is the formula. Okay, let's replace alpha and beta to our formula. So we have now sine 60 degrees plus 45 degrees. Our sine alpha becomes sine 60 degrees. Our cosine beta becomes cosine 45 degrees. Copy the plus sign. Our cosine alpha is cosine 60 degrees. Our sine beta now becomes sine 45 degrees. And after that, we will be needing the exact values of these 4 trig functions using our unit circle. So again, pagsabayin natin ang sine and cosine value of 60 degrees. Okay, this one is our 60 degrees, and we have again 1/2 and square root of 3 over 2. The cosine value is 1/2, while the sine value is square root of 3 over 2. So, ibig sabihin, replace now sine 60 by square root of 3 over 2, while your cosine 60 degrees is equal to 1/2. And again, let's proceed to cosine and sine function for 45 degrees. This one is our 45 degrees. This one is the ordered pair. So, meaning, ang sine natin is square root of 2 over 2, while your cosine is square root of 2 over 2 din siya kasi parehas naman silang dalawa. So, palitan natin to ng square root of 2 over 2. Ang sine 45 natin, square root of 2 over 2 din, then copy the plus sign. Again, this time, let's simplify square root of 3 over 2 times square root of 2 over 2. That will result to square root of 6 over 4. Copy the plus sign, and 1/2 times square root of 2 over 2, that is equal to square root of 2 over 4. Again, we can now add since this one is a similar fraction. So, the exact value now of sine 7 pi over 12 is equal to square root of 6 plus square root of 2 all over 4, which is the same as the first solutions for number 3. Number 4, find the exact values of sum and difference identities for sine. If sine alpha is equal to square root of 3 over 2, tangent beta is equal to negative 15 over 8, while your alpha is greater than pi over 2 but less than pi, and your beta is greater than 3 pi over 2 but less than 2 pi. So, in this problem, we asked to find the sum identity for sine and difference identity for sine. And these are the formulas to find the sum and difference identities for sine. In our problem, we are given the value of our sine alpha. But the rest, the cosine beta, cosine alpha, sine beta, are not given. So we cannot find the value of sine alpha plus beta and sine alpha minus beta kapag wala yung mga trig functions, yung value ng trig functions ng tatlo. So, first is we need to find the cosine alpha, sine beta, and cosine beta to solve our problem number 4. So, to start that, let's find cosine alpha. According to the problem, alpha is in quadrant 2. And we are given sine alpha is equal to square root of 3 over 2. And in our trig functions, that is equal to y over r, meaning y now is equal to square root of 3 while your r is equal to 2. And in finding the value of this cosine alpha, that is equal to x over r. So in this problem, in our given, we don't have the value of x, but we have the value for r. So we cannot find the cosine alpha because we have the missing value of this x. So what we need to do now is to use the Pythagorean theorem and to find the value of x. So that is equal now to square root of r squared minus y squared. Okay, so let's substitute the given value to our formula. So we replace r by 2, and that becomes now 2 squared minus, we replace y by square root of 3. So we have now square root of 3. So let's simplify. X now is equal to square root of this 2 squared is equal to 4, and this square root of 3, that is equal to 3. And by subtracting, that is now equal to square root of 1, and square root of 1 is equal to positive negative 1. And according to our problem, our alpha is in quadrant 2. So we have now the negative and positive. According to the quadrant 2, your x should be negative. That's why your x here now is equal to negative 1. And after finding the value for x, we can now have the value for cosine alpha. And your cosine alpha now is equal to negative 1/2. And this one now is our final answer. So this time, let's find the value for cosine beta and sine beta. In our problem, it was stated that our beta is in quadrant 4. And in quadrant 4, we have the positive and negative. So, from the given, we have tangent beta is equal to negative 15 over 8. And according to our trig functions, that is y over x. Therefore, the value for y is equal to negative 15, because in quadrant 4, the y should be negative. And we have x is equal to 8. And in finding cosine beta and sine beta, for cosine beta, that is equal to x over r, while your sine beta is equal to y over r. In our problem, we are given the value of x, the value of y, but we don't have the value of our r. So, we need to find first the value of r before finding the value of the cosine and sine beta. And to find that, we will be needing our Pythagorean theorem, Pythagorean formula, And since we're looking for the r, it becomes now r is equal to square root of x squared plus y squared. So by substituting the formula to the given value to our formula, so we replace x by 8, so becomes now 8 squared plus our y is negative 15, so we have now negative 15 squared. And let's simplify, so 8 squared, that is 64, plus the negative 15 squared, that is 225. And we add 64 plus 225, that is equal now to square root of 289. And by simplifying, that's square root of 289, that is the positive negative 17. But according to the rule, r is always positive. Therefore, r is equal to positive 17. And after finding this one, we can now find the value of our cosine beta. And that is equal to 8 over 17. While your sine beta is equal to negative 15 over 17. So after that, you can now find the sum and difference identity for sine. So we have now the value of cosine alpha, cosine beta, sine beta, and sine alpha. So this time, we can now find the value of our sine alpha plus beta and sine alpha minus beta. But this time, let's find first the sine alpha plus beta. So this one is the formula. So let's substitute all the given values in our formula. So let's replace sine alpha by square root of 3 over 2. So this one is our sine alpha, square root of 3 over 2. Our cosine beta, so this one is 8 over 17. Copy the plus sign. Our cosine alpha is negative 1/2. So this one now is negative 1/2. While our sine beta, this one is our sine beta, that is negative 15 over 17. So after this one, let's simplify. Square root of 3 over 2 times 8 over 17, that is equal to 8 square root of 3 over 34. Copy the plus sign. And negative 1/2 times negative 15 over 17, that is equal to 15 over 34. And this time, similar fractions, simply add the numerator and copy the same denominator, meaning our sine alpha plus beta now is equal to 8 square root of 3 plus 15 all over 34. Using the same values, we can now find sine alpha minus beta. And here now is the formula. So what are we going to do now is substitute the values to our formula. So our sine alpha now, this one is our sine alpha, that is square root of 3 over 2. So we have now square root of 3 over 2. Our cosine beta, we have 8 over 17. Copy the minus sign. Our cosine alpha, we have negative 1/2. Our sine beta, we have negative 15 over 17. So after this one, we can now simplify. Square root of 3 over 2 times 8 over 17, that is equal to 8 square root of 3 over 34. Copy the minus sign. Negative 1/2 times negative 15 over 17, that is equal to 15 over 34. Since this one is a similar fractions, we simply subtract the numerators and then copy the same denominator. So we have now sine alpha minus beta is equal to 8 square root of 3 minus 15 all over 34.